Good morning. Today's precalculus problem is finding all asymptotes of this function. So this type of function, if you don't already know, is called a rational function. Whenever you see the word rational, we're usually talking about a fraction type of expression. Like a rational number is just an ordinary fraction, one half, two thirds, something like that. Um, so a rational function is a function where you have, in this case, two polynomials written as a ratio. So a ratio of two polynomials. And most of the time when you're studying these in precalculus, you're going to be mostly concerned with the asymptotes. So we have vertical asymptotes, which could look something like this, or they could be going in the same direction up to infinity or both down to negative infinity. You could also have horizontal asymptotes where you have something like this. Something like that where it approaches that horizontal line, but it never actually crosses it. You could also have what's called an oblique asymptote. And so this is where I have something like that. And so this is an asymptote that is not horizontal or vertical. So in this case, this line would get close to the asymptote, but never actually touch it. And so we're interested in finding these. Now, you cannot have a horizontal asymptote and an oblique asymptote on the same function. You could have the vertical with either one of these, but these two are mutually exclusive. So you'll never have those two together on a rational function. So how do we go about finding these? Well, let's talk about the vertical asymptote first. So the vertical asymptote, to find that, set the denominator equal to 0 and then solve for x. So this is just standard uh, factoring and then setting equal to 0. So let's set the denominator equal to 0 and see what we can do. So this one, it doesn't look super easy to factor at first, but we at least know we can factor out an x. And we're left with 2x squared plus 5x plus 6 equals 0. And so now, what can we do with this? Um, I don't see an easy way to factor this immediately. So one thing you can do to kind of check this, 2 times 6, and multiply the first coefficient by the last coefficient, which is 12. Now list the factors of 12 and see if any of the factors of 12 will add up to 5. And it doesn't look like they do. So this one's not going to factor, but we could still have an irrational solution to setting this equal to 0. So let's use a quadratic formula and we'll see. Actually, before we do that, so the part of the quadratic formula that is under the square root, the b squared minus 4ac, we can actually see if we'll have any real solutions. And if we don't have any real solutions, we don't really need to worry about the rest of it. This would be called the discriminant. So the discriminant would be 5 squared. So a is 2, b is 5, c is 6. So 4 times a times c, and so this is 25 minus 48. So this is less than 0, which means no real solution. So in fact, this will not factor, and there's no real solution to that, setting that equal to 0. So the only vertical asymptote in this case would be x equals 0. Most of the time, it's pretty easy to factor these. Most of the problems that you'll see in precalculus probably are going to be a quadratic. This one does work out to a quadratic once you factor out the x. Um, but as long as this does not factor into any real factors as opposed to complex factors, um, then you don't have to worry about this creating any vertical asymptotes. So the vertical asymptotes happen wherever the denominator equals 0, which is why we are setting this equal to 0 and solving for x. Um, so only vertical asymptote in this case is x equals 0. So here's an example of a function with a vertical asymptote at x equals 0. So you can see as we get closer to 0, this function goes down to negative infinity as we're coming in this direction, goes up to positive infinity if we're coming from the positive direction. Okay, now horizontal asymptote, which is easier to check. So I said a few minutes ago that we only have either the oblique or slant, sometimes it's called a slant asymptote, or we have a horizontal. We do not have both. So the horizontal is easier to check. If you don't have a horizontal, then you can check for the oblique. So for the horizontal asymptote, we really just need to, this is actually easier. It's a little bit more to remember, but it's easier to find. So check the degree of the polynomials. So the degrees of the polynomials are whatever the highest exponent is in that polynomial. So we have on top in the numerator is degree 3 because we have the cube. The cube is the highest exponent. In the denominator is also degree 3. Now we'll go through all the possible scenarios. The first one, of course, that we do have is that the degree in the numerator equals the degree in the denominator. And so what that means is we're going to take the ratio of the leading coefficients. So we have 6 divided by 2. So the horizontal asymptote, which is a y equals some constant, that's the equation of horizontal line. So y equals 6 over 2, which is 3. Now, it just happens that the degree is the same as the asymptote. That doesn't mean anything. If these were both 4s, the horizontal asymptote would still be y equals 3. So that doesn't mean anything. It's just coincidence that they're the same. But if the degree on top equals the degree on bottom, you take the ratio of the leading coefficients and set it equal to y. So horizontal asymptote is always y equals, vertical is always x equals. All right, let's talk about the other possibilities. So if the degree on the top is less than the degree on bottom, so say we have a degree 2 polynomial up here and a degree 3 or 4 or 5 polynomial down here, then what happens is the as x increases, so we're essentially seeing what happens as x goes to infinity or to negative infinity. As x gets bigger and bigger, and let's just say is x squared plus 1 over x to the 5th minus 1 or something like that. As x gets really, really big, this gets really, really big. And it gets bigger. This will also get really big, but not as fast. So, and you could try this plugging in large numbers, and you see that the ratio between those two numbers is getting smaller and smaller and smaller. So if the numerator, the degree on top, is smaller than the degree on bottom, you have a horizontal asymptote of y equals 0. A very simple example of this is actually this function here. So we have a horizontal asymptote here of y equals 0. This is actually the function 1 over x. And so you can imagine we have a degree 0 polynomial here. We have a degree 1 here. And so what happens is as x gets big, you end up with 1 over a really big number. And that as x gets larger and larger and larger goes to 0. The last possibility is if the numerator is bigger than the denominator, then you have the opposite happening. And in that case, so we'll just flip that one. And you can imagine if this way goes to 0 as x gets really big, that means that this one has to go to infinity as x gets really big. Now, going to infinity is not a horizontal asymptote. So in this case, we'd have no horizontal asymptote, but we would have an oblique asymptote. And maybe we'll do one of those in another video. We're just doing the vertical and horizontal here. So, so we have the x equals 0 for the vertical asymptote. For the vertical asymptotes, you set the denominator equal to 0, solve for x. Now, one thing you do want to make sure you check before you say that whatever you get for x is a vertical asymptote, you do need to well, it's kind of assumed. We need the rational function to be in simplified form. So what that means is you factor the top as much as you can, factor the bottom as much as you can. Anything that crosses out would not be vertical asymptote. That would actually be a hole in the graph, which we'll probably talk about those in another video as well. But before you start finding all these, you really need to make sure that you're in simplified form. Factor everything, cancel everything out. Then you can set the denominator equal to 0. Anything that you're left with um, that would make that equal 0 is a vertical asymptote. And then for the horizontal asymptote, check the degrees and then compare the degree on top with the degree on bottom. In this case, they're equal. So we have a horizontal asymptote of y equals 3. Okay, so this is kind of a lot of information. Not a lot, but it is a little bit of information. And so the best thing, these are not super hard as far as the math goes. It's more just kind of remembering the rules. Um, and thinking about these because it does make sense. Um, these different rules here. So the more you kind of think about them and work it out on your own, the more it makes sense. And same thing for this. If we're talking about the function going to infinity, that means we need something over 0 or something approaching 0. So if you have any other problems you want me to do, or you have any questions or comments, feel free to leave those in the comments.